All right, so we're looking at problems 42 to 46. 43 to 45 are virtually the same question. So completing the square, I'll show you the geometric aspects of it. You've seen it numerous times before, and if it looks as though you're seeing it for the first time, then it's time to work a little harder. This has been done in several videos and it's been done in class. All right, x squared plus 6x is a rectangle. That is not a square. The sides are not equal. Minus 11. We are going to write that as if it was turned into a square. Right now, I have x squared plus 6x, right? When I multiply. So how do you make this a square? You make the longer side shorter, the shorter side longer. And if you do, you're coming up with x plus 3 times x plus 3. Virtually just cutting the 6 in half, keeping it a positive. That's x squared plus 6x plus 9. Okay, I wrote it that way just so it would fit. That area is almost the same as this area, except this area is 9 bigger. If I want it to be the same as that area, I got to subtract 9 to get rid of that 9. Then it's x squared plus 6x numerically. And I got to bring in the minus 11. Okay, and now I have a new calculation, which I will do here without the drawing. And we'll do 4 or 5 of these, at least another 4. All right. So when the coefficient is 1 and that's even, it's easiest to do it this way. Okay, that's easiest to do. So 3 squared is the constant that is not up here, right? Minus, just ignore this number for now, right? Ignore this number for now. That is the same as this. That's binomial squaring, x squared plus 6x plus 9. And then if you subtract 9, you get what you started with. Okay, but this had a minus 11, so it's minus 11. All right, so minus 20 becomes positive square root of 20. Oops, I didn't do the squaring yet. Minus 20 becomes positive 20. Squaring becomes plus minus the square root of. Addition of 3 becomes subtraction of 3. And hopefully you could have also seen that it could have been written as 2 root 5, right? 4 times 5. All right, so let's throw this line of work one time in here so you can see the numbers work. 3 plus minus square root of 20. We'll do it together. What happens? 3 minus 3, excuse me. So minus 3, right? There's got to be a cancellation between the minus 3 and the 3. Rotator cuff problem there. Okay, when you square a plus or a minus, you get a positive. When you square a square root, you get what's inside. And I do believe 20 minus 20 is 0. All right, so now we'll just do another 4 problems quickly. You pause the video each time, and hopefully by the time we get to the 4th problem, it's a topic you put in your pocket. All right, so let's start up here. Let's go x squared minus 10x plus 3. I'm going to write that as x minus 5 squared minus 25 plus 3 equals 0. That's negative 22 becomes positive 22. Boom. Squaring becomes plus minus square rooting. Boom. Minus 5 becomes positive 5. And those are my roots, my x-intercepts. Okay, this is somewhere less than 5. So I'm near the origin with one of the answers, and I'm near positive 10 with the other. Next problem. X squared plus 4x minus 15. All right, I'm going to write x plus 2 squared minus 4 minus 15 equals 0. All right. Minus 19 becomes positive 19. Squaring becomes plus minus square rooting. Positive 2 becomes minus 2. Those are my roots. That's a little bit bigger than 4. Minus 2 plus 4 is a little bit bigger than 2. That's one of your roots. And minus 2 minus 4, you're near negative 6 for the other. Next problem. X squared plus 20x minus 7. So I'm seeing x plus 10 squared minus 100 minus 7. I got to get you some imaginary roots here. Next time I will. All right, equals 0. I guess I'll put it on this line of work. Minus 107 becomes positive 107. Plus minus the square root gets rid of the squaring. addition of 10 becomes minus 10. That again is near the origin too, minus 10 plus 10, huh? And minus 10 minus 10. Okay, I got a feeling for my roots. And the last one, let's make some imaginary answers here. Let's go x squared plus 6x. No, I already did plus 6x. Let's do minus 12x, and let's make this plus 50. All right, that's probably not going to be a real answer. So I got x minus 6 squared minus 36 plus 50. Oh, that's 14 on the right. If that's 14 on the right, then I got minus 14 on the left, which means I got an imaginary, right? Square root of imaginary, and I got a plus minus. And I've got negative 6 or positive 6. And those are your imaginary answers. And an imaginary answer comes from the quadratic not going through the altitude that you're generating. All right, we're looking at. Okay, so that takes care of that. Now we got some logarithmic work to do. And logarithmic work, log base m, means that we're looking at base m in the parentheses. We got to make it base m. And we got to look at the exponential activity. So let's start with m squared to the 5th. Okay, so log base m is asking m to the what? Equals m squared to the 5th. And hopefully from your Algebra 1 class, which is a prerequisite for Algebra 2, you can see that m to the what equals m to the 10. And I hope you say that that question mark better equal 10. So that's that answer. Now I'm just going to play with exponential rules and see if you know them. So let's do another one. Let's look at m to the 8. Now let's look at m to the 80 over m to the 2. Well, that answer is actually 78. Because m to the 80 is m squared times m to the 78. And if I divide by m squared, the m squareds cancel. And I get m to the 78. And oh, I forgot to put my base m here, right? And so what do you put on top of m to get m to the 78? After you work that and simplify it, you better say 78. Okay, let's do some more. Let's look at m to the negative 2 to the 3. Now you're doing m to the minus 2 times m to the minus 2 times m to the minus 2. I think that's negative 6. Yep, that's how many I have. And this is really 1 over m squared times 1 over m squared times 1 over m squared, which is 1 over m to the 6th, right? But I think the rule here appears to be multiplication. Okay, let's try another one. This might have been on the test. M. I think there's an easier way to say I think it's m to the 3. So I guess that answer is 3. That's the exponential activity on top of m. That's what that's asking. All right, one that people had a lot of trouble with, minus 8. Let's do minus 8. And let's divide by minus 2. Well, this is saying m to the minus 8 divided by m to the minus 2. M to the minus 8 is the same as 1 over m to the 8. And this is divided by 1 over m to the 2. And the rule from elementary school is when you divide by a fraction, you multiply by the reciprocal. I guess I should show that. 1 over m to the 8 times m to the 2 over 1. I look at this line of work and I see m to the minus 8 in the numerator, but expressed as m to the 8 in the denominator. And I see m to the minus 2 in the denominator, which eventually gets moved to m to the positive 2 in the numerator. I think I can move negative exponents into the other location. I'm going to do that. I'm going to make the minus 8 positive 8 right here. and the -2, +2 right there. And I think there are 6 more in the denominator. So I think that's the same as m to the 2 minus 8. And that's -6. In other words, m to the 8 is m squared times m to the 6, and m squared goes into m squared once. And 1 over m to the 6 could have been written as m to the -6, and I can see the base m exponential activity. There it is. Try another one. I don't know how many ways I can rewrite this now. Let's try log base m of m to the 5. I don't want odd numbers. I'll make it m to the 8. Let's do m to the 4, and let's do -3. Well, division is simply counting. There's 4 more m's in the numerator. And that's multiplication, so that's -12. Unless, of course, I multiply everything by 5, then it's -60. Because you would do the logarithm first, and then you do times 5. I forgot I asked one of those. So let me do one of those, and we'll do a multiplication by 2. That's easier than multiplication by 5. Yeah. 2 log base m of m to the -2, m to the 7, all to the -3. Well, I know I can move m to the -2 into the denominator as m to the +2. Of course, there's still the number 1 there. And I know 7 and 2 make 9, but that's in the denominator. So I'm going to write not -9. And I know -3 times -9 is 27. And I know the log here is equal to 27, but I'm multiplying times 2. I think the answer to this is 54. Got some practice there. So that takes care of 43, 44, and 45. And then we have to look at some graphing. 46, what's number 46? Oh, my favorite. Just writing answers and getting good at it. X squared minus 8x plus 20. Well, I know from -2 to -8, I can write x minus 6 pretty quickly there to get the first 2 terms. Right, if you FOIL this, you get x squared minus 6x minus 2x, but you also get positive 12. And I got to get from positive 12 to 20. You know, I think it better add 8, but if I'm multiplying by x minus 2 and I just want to get 8, then I got to undo that multiplication. And as I said, for the time being, if that's too big a step, you can write the plus 8 there. But if it's written this way, I can see that a 2 gets rid of that product and gives me 8. So over here, if I put a 2 in, I better get 8, or I've made a mistake, and I make mistakes all the time. So 2 gets me 4 minus 16 plus 20. Well, 20 minus 16 is 4, and 4 is 8. 2 got me 8. I guess I'm moving on. And we'll do 4 more of these. And you can pause the video before you watch me do it. I'm just going to keep moving along, because I got another video to make after this one. X squared plus 9x minus 3. Okay, that's x. To get from -5 to 9, I got to go up 14. And I hope you can see that in the FOILing process, -5x plus 14x gets us that. And then, all right, I've got to get -5 times 14, which is -70. And I got to get to -3. I better go up 67 units. And get rid of that multiplication of x minus 5, where I won't get the constants to work out. So 5 is the user-friendly number. Let's see if that adds up to 67. 25 and 45 minus 3. That's 70 minus 3. I think I'm moving on. Try another one. Later after midterm, we'll be doing cubics. Let's do x plus 3 times what? Gets us x squared minus 8x plus 1. Well, positive 3 minus 8, I think I need x minus 11. 3x minus 11x. Yeah, I can see that. 3 times minus 3 is minus 33. That's the constant k for constant, just like cat spelled with K-A-T. My grandson keeps fighting me on that. I'll convince him. So how do I get from minus 3 to 1? I guess you got to go up 34. And what's the critical number? Negative 3. Let's put a negative 3 over here and see if it comes out as 34. Minus 3 squared is 9, minus 24. Oh, positive 24, sorry. Minus 3 times minus 8 plus 1. That's 33 plus 1. 34. I'm moving on. On to, what was it? On to Cincinnati. Thanks, Bill. All right. How about x plus 5 this time? Times what? Gets us x squared minus 10x. Yeah, what the heck? Minus 10x plus 2. Let's keep the addition easy. How do I get from 5 to minus 10? I think I got to go down 15. There's our 5x. There's our minus 15x. There's our minus 10x. Hope you can see x squared. 5 times minus 15 is minus 75. I got to get to 2. I think I got to go up 77 over x plus 5. You multiply this out, you're going to get that. And I'll do that multiplication for you in a moment. Critical number is negative 5. And I hope you're seeing everything here. Not doing such a good job here. God, repetition's my friend. I should have been standing further over here. Not doing it again. Negative 5. Negative 5 squared is 25 plus 50 plus 2. I'm seeing 77. I'm moving on. All right, so let's do this multiplication one time. Let's do x plus 5 times x minus 15. X squared minus 15x plus 5x minus 75. Then I'm going to do that multiplication. I hope you can see these numbers cancel. Plus 77. Of course, I had to erase this stupid thing. X squared minus 10x plus 2. I do believe that's what we had there a minute ago. All right, so does that take care of this video? Yes, it does. Now we're going to do some graphing. I'm going to give you the functions, but not in this video. It's the last one. And then if we have to test every day till midterm, we're gonna. Because you got to do the work to learn this stuff. All right, I'm on a roll here.